So, very good morning to you. And my today's agenda is to have some discussion about the role of coefficient of correlation in the financial management and also how much we use regression in. If you recall the name correlation coefficient and regression coefficients, they are basically we use them in statistics. So, but there are a lot of statistics formulas which we also apply in financial management. So we should discuss that dimension a little bit today with some examples. So the coefficient of correlation, um, if I have to give a definition of coefficient of correlation, it tells the degree and association, degree and direction of two or more variables at a time. That's what correlation means. If you remember, maybe last week, we were discussing about the diversification, that the portfolio, if it is diversified, I can show you actually, it was here in this picture. Yeah, like this. That if a portfolio is well diversified, you have more stocks, then the firm's unsystematic risk starts falling. So you can see on this red curve that as you are more diversified, your portfolio has more stocks, and the total risk is falling, and the important part of total risk is the unsystematic risk or the unique risk or the firm risk or the micro risk. It declines. So much so that it becomes nearly, this curve become parallel to x-axis. Of course, the curve doesn't, this curve never touches zero horizontal axis because some market risk or systematic risk or macroeconomic risk or business risk would always remain. So that is why this curve would never touch x-axis. But the point I'm trying to make here is that if your portfolio is well diversified, then your unique risk declines considerably. But there's a one catch in it. The catch is that the quality of diversification. Now imagine you have 1,000 euros to invest, and you are investing all your money in, let's say, in BP, the British Petroleum. In the second situation, you split up your 1,000 euros and you invest in BP, in Shell, in Total, in Statoil, in Norway, and Occidental, and a few oil companies. So basically all the money which you invest is either in the same industry or in the same sector. So it means that despite your portfolio is so-called diversified, but the quality of diversification is very low because all the macroeconomic factor which affect BP will also affect Shell, will also affect Total, will also affect the other oil companies. Okay, same way, you cannot say that if I have two stocks of Pepsi, I'm less diversified, but if I have one stock of Pepsi and one of Coke, I'm more diversified because Pepsi and Coke are pretty much, they have a lot of similarities. And how do we say that there is a lot of similarities between them? It is because the coefficient of correlation between Pepsi and Coke's stock return is expected to be, because basically they are in the same industry. Same way, the coefficient of correlation between the oil companies, which I mentioned, is expected to be very high because they are in the same industry. In the same way, you can take any 3-4 companies in a given industry or sector and try to match their stock return and find the correlation between them, and you will find that the correlation between the stocks is pretty much similar, pretty much, correlated, I should say, correlated. More the correlation, lesser is the quality of diversification and lesser would be the risk. I mean to say that if the coefficient of correlation is high, then your risk management is not so good, because more correlation means either they increase together or they decrease together. So basically, you are not able to reduce your risk. You can reduce risk if you are qualitatively correlated, well correlated, well diversified, uh, qualitatively well diversified. For example, a situation is that you have one share of Coke and the second of Pepsi. Compare it with one share of Coke and the second share of Finnair, for example. So now if you see the correlation between Coke and Finnair, it is very, very less basically, because these two companies come from two separate industries, two separate sectors. But if you have one stock of Coke and the second of Pepsi, you are not so diversified for two reasons. First of all, Coke and Pepsi are in the same industry. And secondly, Coke and Pepsi are based in the same country. So there's a country risk also. You know, the macroeconomic risk of USA would also affect your stock return. On the contrary, if you have one stock of Coke and the second of Finnair, not only that these two companies are belonging to two different industries, but there is also that they come from two different countries. So when you invest in Coke and Pepsi, you have two-stage diversification. You are investing in the two different companies, and at the same time, you also minimize the country-related risk. So therefore, it's very important that the quality of diversification is improved, and the quality of diversification is improved if the coefficient of correlation between two or more stocks is less. Now, I want to give you an example for this. And that example is actually in your Optima. So I want to discuss this picture first, and I will prove it with the real data that how this picture is true. If you look at this pink curve, this is the efficient frontier. And if you look here, we are calculating the standard deviation on the horizontal axis. And on the vertical axis, we are calculating expected return. It could be either way. It could be expected return could be on the horizontal axis, and the standard deviation, the measure of risk, can be on the vertical axis. No problem. That will not change anything, basically. The point here is that if the correlation, and I hope you remember, you know that the coefficient of correlation has a quality that it cannot be less than, it can never be less than -1, and it can never be more than +1. So the range of coefficient of correlation is always between -1 to +1. If ever you do some correlation numerical question and you happen to find correlation more than 1 or less than -1, then you must have made some mistake somewhere. So the coefficient of correlation is always +1 and -1. And you see here, when the correlation is highest, +1, then for the given risk, the return is less. But when the coefficient of correlation is the least, -1, then for the given risk, the return is more. So you can see here that here return is this much, and here return is this much. So the point I want to prove here is that if the correlation of coefficient is very high, then for the same level of, for the same amount of risk, the return will be low. Or for the same amount of return, risk would be higher. And in the second situation, when the correlation is the least, like here is -1, then for the same, level of risk on the horizontal axis, the return would be higher or rather highest. or for the same amount of return, the risk would be the lowest. Okay, so the coefficient of correlation, which determines that how well correlated, how well associated, is a sign of riskiness. So your entire strategy of diversification will go downhill if you ever happen to choose two or more stocks with very high coefficient of correlation. So when you are a fund manager and you have an investor who is risk averse, and the risk averse investor, you know that he or she wants to have the lesser risk, and you happen to give him or her advice that, you know what, if you have chosen more stocks, then you are well diversified. And if you're well diversified, your unsystematic risk will go down. But what you're recommending this investor is to buy in all the oil companies. That would be a very big mistake on your part. Then even though on the face value, apparently you are making this investor to go diversified, but the level or the quality of diversification is very poor because of the high correlation between these different stocks. So be careful that when you are recommending different diversified portfolio, you make sure that the industry, the companies which you recommend should be in the different industries, in the different sectors, and if possible in the different countries also, so that you can minimize the country risk, the country's macroeconomic risk as well. So these are the few things which you need to keep in mind. And this picture is very evident that if the correlation is very high, you have given some recommendation to pick up all the oil companies in one portfolio, then for the given return, risk would be, for the given risk, a return would be very low, or for the given return, risk would be very high. In comparison to a situation when the correlation between these stocks is very less, -1 is the least, then for the given risk, return would be higher, or for the given return, the risk would be lower. So either way, you need to be careful that what type of recommendation you're giving. And now I want to show you one spreadsheet, and that would prove that what I'm saying is also empirically true. So may I, where is the spreadsheet? Oh yeah, it's here actually. So if I can share it with you, yeah, I hope you can see it. If can't, let me know, yeah. Here, I have my hypothetical portfolio. And in this hypothetical portfolio, I have two stocks. And the return on the stock is, on X is 10%. And the return on Y stock is 15%. Whereas the risk on X stock is 20%, 0.2, and the risk of Y stock is 0.3, 30%. And you know that the standard deviation, SD, is a measure of risk. And then we have different combinations of, for example, here we have a portfolio where we have 20% of X and 80% of Y. And then the other extreme is we have E portfolio where we have 80% of X and 20% of Y. So basically, because Y is giving you more return, but at the same time, more risk. So we can assume that on the portfolio A, the overall risk would be lower for the given return because the overall, I shouldn't say that for the given return, but the overall portfolio risk would be lower at A, but the overall portfolio risk of E would be higher because here you have 80% of X. No, I said opposite. At E, you have 80% of X and X has lower return and lower risk. On the contrary, the A portfolio, you have 80% of Y, which is more return and more risk. So in other words, the portfolio A is expected to give you higher risk and return in comparison to portfolio E, which will give you lower return, but at the same time, the lower expected risk as well. Okay, so now we carry on, we make this portfolio and we have this, as the formula suggests, we have the portfolio return. Obviously, A portfolio will give you more return. And here, there is standard deviation. There is a formula how to calculate it, but you don't have to go by this formula actually. You can just type in this formula I used because this is the actual formulation of the risk formula, that how to formulate the risk itself. But because we can also use the Excel function and we can use the standard deviation, so that's not a big deal. But see what here. Here, I assume that the correlation between X and Y is 1. So I might have recommended that X and Y are almost similar stocks. So for example, Coke and Pepsi. And you can see here that when the correlation between the two stocks is 1, then their risk is high. How do you know this risk is high? Let's compare only A portfolio. Compare A portfolio when the correlation is 1 with A portfolio when correlation is 0. No correlation between two stocks. So it could be possible that one is the airline stock and the other one is McDonald's, for example. So there is no real visible correlation. So when the correlation between X and Y is 0, then you can see that the standard deviation, a measure of portfolio risk, is the least. You can see it's only 5%, whereas here it was 7%. Because here the correlation was 1, the highest possible. Here there is no minus one that the total. Am I audible? So in the third situation, the correlation is -1. I'm only comparing A portfolio. I can compare all other portfolios also. But the point here is that I'm only looking at the A portfolio. The A portfolio, when the correlation is the highest, for the same return, the risk is the highest. But for the A portfolio, when the risk is the least, I mean, the correlation is the least, because the least can be -1. It cannot fall below -1. It cannot be more than 1, and it cannot be less than 1. It means correlation. Correlation always lies between -1 to +1. And when the correlation between the two stocks is negative, which means they move in the opposite direction, then for the same portfolio and for the same return, 14%, the risk is the least. So you can see that when the correlation is the highest, for the same return, risk is the highest. And when the correlation is the least, then for the same return of the portfolio, the risk is the least. So which means that more the correlation, more you are exposed to the market risk, and hence, and the coefficient of correlation would be a big factor in determining this phenomena. So be careful that when you make a recommendation, it should also be based on the diversification, right? And here you can see this picture is almost similar to what you saw in the slide. that for the same return, the risk would be the highest if the correlation is high. So be careful about it. Okay, any question about the correlation thing? If not, then we move on to our slide back. And let me see if I'm sharing it with you. Yeah, it is. The next thing we will talk about, actually, we have discussed it before. It's beta. Beta is a measure of the systematic risk. Beta shows how responsive or how sensitive is your stock return to the market changes. If your beta happens to be, let me show you one example. Beta is often given on the finance web pages, but in this course, we shall study that how we can calculate our own beta as well. Let me share the screen with you. I hope it's getting shared. This is the Yahoo Finance, and I think I mentioned many times that I use this web page quite frequently. It's really good, very user-friendly. Now, if I look for the stock of BP, like British Petroleum, should I only type in BP? BP. Yeah, so BP PLC, New York Stock Exchange. And I can show you that here is beta of, for the last 5 months return. 5 months are not enough time. So anyways, but 5 years. For the last 5 years, but monthly beta. So not daily beta, but monthly beta, but for the last 5 years, which is quite good. It happens to be 0.48. So basically, the stock exchange in this case is New York Stock Exchange. So I can say that when the NYSE index increases by 1%, the BP's stock return will increase by 0.48%. And if BP's if the NYSE, New York Stock Exchange index, goes down by 1%, then British Petroleum's stock return will go down by 0.48%. So it shows the sensitivity of an individual stock return to the market movements. Higher the beta, more it gets risky, actually. Generally, we say that if your beta is more than 1, then that stock is risky. Because if imagine this beta was not 0.48, but 1.48, it would show that the BP stock return increases or decreases, may increase, may decrease, disproportionately higher in relation to the market movement. But here, when the market is very good, like it increased by 1%, the BP stock return goes up by only 0.48%. But if the market is down by 1%, the BP stock return goes down by 0.48% only. So it means the attachment of this stock with the market return is not as profound, as prominent as it could be. So if the beta is in the range of 0.75 and 1, less than 1, basically, then that often is said to be a choice for the risk neutral investors. And if the beta is below 0.75, it is presume that this stock is meant for the risk-averse investors. So here beta is 0.48. So I can assume, I can make some kind of arguments that this stock is more suitable for the investor who doesn't like to take risk much. Of course, you take risk when you invest in the stock. The question is that how much is your risk stretchability, risk appetite? So for the low risk appetite investors, BP is a good choice. And for the risk lover type of investors who really love to take risk, this is definitely not a good choice. Okay, so beta, but this beta is by the way published beta. Published means it's a headline beta. So we haven't done this calculation. So this is the theory behind beta, that this shows the responsiveness. I go back to slide again. So beta essentially, if I have to say in terms of statistical words, it's a slope, it's a ratio of covariance between stock return of a company and the market stock return, and that you divide by the variance of market return. You don't have to memorize it, because I will never ask you to give me the formula in the exam, because why should you give? The idea, the understanding of beta is more important, I think. The index can change from exchange to exchange. If you are in Finland, we may use OMX Nordic Nasdaq index. If you are in UK, then you can use FTSE 100 or FTSE 250. If you are in the US, then you can use S&P 500. If you are in France, you can use CAC index. If it is a German company, you may use this DAC, the DAC. So we depending upon the exchange you work in, where your company is listed, you may use that index. And then, of course, there are some global indexes also, like S&P 500 is used globally. So depending upon what you use. Yeah, so these are some of the sources where you can get the beta published. But my intention is something else. I want to show you how to calculate the beta. And then for this purpose, I need to go back to Optima. And in Optima, where is I'm sharing the screen. It's very important that I don't forget it. If you go to study material and you see the spreadsheets, in fact, there's so many companies beta I have. I have Kone's beta, Nokia's beta, Microsoft's beta I have, and then basically different companies, I would say. So if I happen to choose, for example, Finnair, let's say, Finnair return and risk. Yeah. So this is Finnair. This is the last year I actually calculated this. I made this calculation last year. But here you can see that I downloaded the data of Finnair. Let me zoom in if it is not visible. So this is the Finnair data, and I took the time period from 2nd of October 2019 was the latest period, and I went as far as no, not that far, maybe 3rd of October 2014. So it's about 4 to 5 years data, which is not bad. To calculate beta, I think 2 to 3 years should be the minimum period. And then I have the Finnair stock return, the stock price. I wonder why the formula is not appearing. Then I have to, but anyways, just a sec. The formula is appearing here, but not here. Well, we can find out, no worries. Yeah, so this is Finnair stock, and we need to calculate the Finnair's return. I'm not very convinced why the formula of calculation of return is not appearing, but we can do it now, no problem. So if I basically take the current price minus the previous price, and I divide by the previous price, you have to see the order of the data. Sometimes the data is given from the oldest to the latest, then you have to change the formula. So be careful about it. Oh no, this is, I know the problem. I think this is the formatting problem. This is not a date, come on. This is a number. And the number is in how many places?
Sharp, as I see you calculating date, no Finnair price. Column A.
Yeah, I think so, yeah. So let's go to B2, sorry. Coffee intake, yeah. Caffeine deficiency, but thanks, there is somebody awake. So this is how we get it. We can actually increase the number of, because this daily basis, this increase can be very minor. So it's good that we have more decimal places. All right, the same way we have the Nordic index, and then we can calculate the Nordic return, index return. So which is same as current value minus the previous value divided by the previous value, and then it happens to be like this, and then you can just do it, and then it goes on. We calculate the return of Finnair here, which is the average daily return, but remember this is the average daily return. For the comparison purpose, for the more analysis purpose, we try to make it the annual return. So what we do, we make it annualized, and the formulation is given that you have the, you put the exponent 1 plus daily return, and then we use the exponent function 365 days minus 1, and that will give us the, so in other words, the return of Finnair a year, the average annual stock return based on the daily stock value, Finnair has been earning, providing return to its investor 46, almost 47% on yearly basis from 2019 to 2014, which is really cool, really good. And if you look at the risk of the Finnair stock, it has been 2.38, so 3822% on daily basis, which is quite a lot. And when you annualize it, it becomes almost 45%. So it seems that the Finnair is providing very good return, but at the same time, the risk level is fairly high. On the other hand, you have the return of the daily return of the Nordic index, which is 0. This value, but you can also annualize it And when you annualize it, it comes to be this, the same formula. And when you find the risk, it is this. But when you have to annualize the risk, it comes like this. So basically, it's very evident that Finnair has been quite, in comparison to the market, in comparison to the Nordic index market, Finnair has been producing more return compared to these two numbers. And at the same time, Finnair has been risky also. And then we can calculate the coefficient of risk as well, which is for the given, you can see here for Finnair, I divide return to risk. In other words, for 1% risk, Finnair is providing 1.022% return, whereas the market, for the 1% of risk, market has been providing 0.261 return percentage. In other words, when we have a common denominator, it appears that Finnair's performance overall in terms of, for the given risk, Finnair has been given more return to its investor, but definitely Finnair seems to be riskier than market apparently here. But let's check it. 1256, okay. So how do we calculate the beta? I thought there is a beta here, but I don't have it. No worries, we can calculate it. So if I say beta, then we can have the slope function. And because Finnair return is starting from C2 and it goes to C1256, I think. Yeah, that's a 1256. And then I choose the index. Always take the Y value. Y value means that the one who depends. Remember, it's the Finnair stock return which depends on the market return. It's not the market return that depends on the Finnair stock return. So Y means the dependent variable, the one who depends. And X means the independent variable, the one which affects. So that's why we always take the company return first, we choose, and then separated by semicolon, you can see here, and then we pick up the index return, which is F2 to F1256, and I hope it should work. So you can see that the beta, even though it seems to be the total risk of the total risk seems to be quite high for the company, but the market risk is very low, which is a beta close to 0.04 is very less. So we make a very interesting observation that until last year, 2019, even though the total risk faced by an investor who invests in Finnair is way above the overall market index risk, but when it comes to systematic risk means when it comes to the risk which come from the market factors like inflation, exchange rate fluctuation, what it could be, the interest rate fluctuation, inflation, interest rate, some macroeconomic factors, the GDP fluctuation, it could be even some political crisis. That risk is very less. That risk is very less. And this is how we can find out beta. Maybe I'm missing one thing. We can also calculate how much risk come from which source. And as you can see that the total risk, if I can type in total risk, which if you invest in Finnair, your total risk is essentially D12, yeah. And if you compare beta, which is this. But one more variable I'm calculating here, and that is variance, market variance, market variance. And the market variance, if you know statistics, basic statistics, variance is the square of the standard deviation. So if you can find out the standard deviation of something, just square it. So the market variance is basically equal to, I can calculate here, variance. Does it show anywhere? Oh yeah, it's here, variance, F2 to F1256, and that will give you the market variance. And the market variance is often expressed in percentage, so I can show in the percentage format, number, maybe percentage. If I can have more than about 4 decimal places. So this is what we have. And essentially, the market risk is the product of beta and the product of beta and the market variance. There we go. This number is too small. So if I reformat it and I make a percentage and a bit larger. So this is the market risk which the investor has faced until last year. And the firm risk, which is the unsystematic risk, is basically leftover risk. So I can say that from 2014 to 2019, the FinAir investor has faced almost no market risk because it was so less. So here you are able to compare the risk of a company stock with the index, number one. And number two, you are able to decompose, you are able to break up the total risk the company is exposed to into the market risk and the firm risk. So the market risk is also called systematic risk, macroeconomic risk, business risk, whatever. The firm risk is unique risk or unsystematic risk or the micro risk. So you can see that most of the risk which is coming, which is affecting the FinAir stock is coming within the company, but not from outside. So it's very important that most of the risk is internal risk, the homegrown risk, not coming from the macroeconomic factors. So it means that the overall macroeconomic climate has been very, very conducive to FinAir for the last 5 years. Not 2020, because this data is for the last year, 2019, 2014 to 2019. So this is how we make this basic calculation, that how we split. We calculate risk, we calculate return, we calculate risk. We do the same thing for the market, and then we compare whether the company has performed better for the given risk. So here you can see that for the same risk, the return of FinAir is high, or for the same return, the risk of FinAir has been low. So you can see either way, you can make some comparison, and then you are comparing FinAir with the, you can find out the systematic risk that the company is exposed to, and then by calculating the market variance, which is the index basically, You can also find out the total market risk. And then once you have the total risk, which is, is standard deviation, you can find the difference between the two, and that would be your unsystematic risk. I can actually write it down so that this is clear, at least, that this is unsystematic risk. And this is also called systematic risk. There we go. All right. Any questions, any queries you have about so far that we discussed? Mm-hmm. Okay. So I would recommend you that you should go to Optima and please get yourself familiar with the, am I sharing it with you? Yeah.
Yeah, you're sharing.
Good. So in that case, you should be comparing some of the betas. Let's see for the curiosity's sake that what has been the beta of Nokia. I will not do the calculations, but see if, because this spreadsheet, I think I calculated last year, so it's, or maybe last semester. Let's check. So this is Nokia. I took the data. Oh yeah, this is also last year. So I took bid price, ask price, but we always take the closing price. So that's our main. And then same way we have the NASDAQ return value, and then we have the NASDAQ. So I think the formula is, yeah, here and then the beta was actually 0.66, which means if you compare beta, because the time period is almost same, and how many observations I took? This is even longer, because you see the number of observations are highest is 2534, which means it must be 10 years. So here I calculate beta of Nokia for the last 10 years. I can actually show you so that you believe me what I'm saying. Yeah, it's 2009 starting from. And here when we have the beta, it comes to be 0.66%. Beta is never shown in percentage. Beta is always a coefficient, not in percentage. You can modify, you can change your risk, whatever, to percentages, return to percentages, annualize it, whatever. Never try to annualize beta, because beta is a slope. So either it's for short period or long period, the slope remains common. It's a mathematical property that the slope of the line, straight line, is always constant. So that is 0.66. So it's not as less risky as Finnair Nokia was. So beta is, I will still say that it's not very high. It's not very risky thing, but when you can compare that for the 5 years data, for Finnair, it was almost close to zero, which is very rare. But for Nokia, it's pretty high. Then not a bad idea to check another very famous company, Kone. Kone is another classic example. Yeah, Kone. Open the file. Kone is Kone is very risky. It's 0.90, but I won't say very risky, but it's quite close to the one. Okay, and this is 2 years ago, and this also I think this was for 6 years. Yeah, yeah, and yeah, so it's 0.90, and we also have this Kone comprehensive calculations. This spreadsheet I will discuss with you tomorrow more in details because I have something else to discuss with you also. But one more beta we see. We have Microsoft. No, no Microsoft. Only Finnish companies. Oh yeah, we have Volkswagen, by the way.
Microsoft is also there
Oh
above
yeah. Oh
Cone.
yes, yes. Yeah, now I can see. Yeah, yeah. Because I was thinking that I once calculated Microsoft's beta also. So this is Volkswagen, and what's wrong with the value? Why doesn't show up? I don't know what's wrong with this. Maybe I have to change something with the file. But let's see Microsoft. Yeah, that's I think I need to revise the data because this is quite old, 2017. Sometime I just get it and I share it with the students. So maybe some of the spreadsheets I need to take down. So yeah, 0.40, not much. Based on, but this calculation is based on how much? How many years? 2010. So the time is okay. All right. So basically, I don't want to discuss anything more today. And the reason is that there is something more to discuss, of course, but I want to do it when we meet you in the classroom tomorrow. I want to show you those little bit next step calculations. That beta is not the end. Beta is in many cases just the beginning of when you start analyzing risk and return of the company. So I think we shall do more when we see each other tomorrow in the classroom. Yeah. So that's it from me today. So we have a shorter session, but you have a lot to do. You need to understand the concept of beta today and also have a look at some of the spreadsheets and optimize, make your own observations, and why not do some calculations also. So do some calculations too. So that's it from my end, and thank you so much and have a lovely day.